cheat sheet down here. Alright, let's start up mininet. So this is the exact same command that is in your assignment. So I am telling mininet I'm going to have a remote controller. I'm not actually going to run a controller. I'm going to do it manually. Right? But this way, mininet is not starting something up internally that's going to mess me up. Okay? Alright, so let's do the same thing. We're going to tell, we're just going to use OpenFlow 1.3 so we're consistent all the way through. And then there's this command that allows me to show all the flows that's currently in that switch and nothing there, which is kind of what we said. Yes, ma'am?
Could you zoom in on that?
Say again?
Could you zoom in on that text? Could you zoom in on your terminal?
The what?
Zoom in.
Zoom in?
Mm-hmm.
I can try to. There's room. Like this? Is better? Okay. Okay. Now, in order to do this, the way I would go about it is I would start up TCP dump on two windows. Why would I do that? You can see what's going on. TCP dump is your friend. It shows you the traffic going by. Alright, so let's do that first. And so sorry, these are not going to actually be this. These are extra. So we'll do H1 and H5. So I'll just tell you what I typed here because you guys in the back probably won't see it unless you have really good eyes. TCP down -n -I. Actually, let me see what the interface name is first. config play. So TCP down -n -I H1 be 0. TCP down. There you go. Now I have a TCP dump on H1, right? So I can see what comes will go on H1. Yep.
In the assignment, we ran Wireshark on like the host machine on the loopback address, and it seemed like that was going to give us the same packets, even though it was like simulating them when it sent it to the controller. Is that correct?
I'm not actually sure. It might only show you. I'm not sure. I was going to say it might only show you the traffic going to the controller.
Right.
And I'm not a graphical person, graphical user interface, but I'm always default to TCP dump. But yeah, I mean, you're right. If you can, so the problem with if it's true what you're saying, that is good. But of course, that's going to give you everything in the network, right? Whereas my approach, I'm like, oh, I see what's going on here, I see what's going on there. It just makes it easier. But I mean, if that works, it works. All right, where are we? So then on this one, we're going to start another TCP dump. What's the -n -I, by the way? So -n says don't do a lookup, right? Otherwise, if there's an IP address, TCP dump will try to resolve it to show you the host name. So -n just says, just give me the IP address. I don't care. And -I says the interface I want to use. Alright, so our TCP dumps are ready to go. So now let's think about this again, right? So we have, remember we went through that whole sequence of things and we said we're going to use ARP to trigger things. Remember that? What is ARP again? Give me some, show me you're still with me and awake and so on. Yep, go ahead. Address resolution protocol. How are we going to use it in this case? Somewhat.
So you're going to say something like, who has this virtual IP address? The switch will receive that and then pick one of the two MAC addresses to send forward.
So we're going to use ARP to kind of trigger this thing because we know when I do ping with an IP address, that ping packet is going to go down this stack and it's going to get to the MAC layer and it's going to say, I need to put this in the MAC layer frame. What MAC layer address do I need to use? And it's going to do ARP for that. Now let me tell you this. Doing the ARP part of this assignment is arguably the most difficult piece of it. So let's sidestep that. Let's simplify our lives a little bit. How can I simplify my life? Yep. I can manually set the ARP table. So now, we're going to do that, right? So if I manually set the ARP table, the packet's going to go down the stack, it's going to get to the link layer, and the link layer says, oh look, I have a MAC address. I'll just use that. I won't issue an ARP. Okay? So now I simplified the problem. All clear? Right, so let's do that. And because of the way we started off mininet, all our numbering is very clean, right? So I don't have to think too much about this. So I can do, I should have done this before I started TCP dump. So on these, I'm now going to say ARP minus S, this is the command, right? IP address, MAC address. So on host 1, I'm going to say ARP minus S. What is the IP address that H1 will want to use if H1 is going to ping the virtual IP address? What will that IP address be? 10, 0, 0, 10, the virtual IP address. Yes? Everyone clear? Okay, so 10, 0, 0, 10. Now we want to map this to a MAC address. Now let's just suppose that our first load balancing thing is going to go to H5, right? I already have a window on H5. So we're going to just set this up and we're going to say 0, 0, oops, too many. 0, 0, 0, 0, 0, 0, 0, 5. Let me see that. 1, 2, 3, 4. Okay. Boom. So now if I do an ARP here, actually I should have showed you the ARP beforehand. And sorry for the guys in the back, but what it says here is, if I run ARP, it says for 10.0.0.10, Ethernet hardware address, that's the MAC address, and it's to what I just said. Boom! I don't have to deal with ARP, at least not while I do my development. Okay? Well, now let's do the same thing on the other side. And so for those of you who can see this, if I run ARP, nothing there. Right? Because in my little network, no traffic flows, so there's no ARP that has taken place. What do we want to set this one to? Okay, so this is now our real server. It's going to get, if everything works well, it's going to get the packet coming in, right? The packet is going to be from 10.0.0.1. It's going to go to 10.0.0.10, but we're going to flip that IP address, so it's going to look like it's come from 10.0.0.1, and it's going to go to 10.0.0.5. So H5 will want to send a response, so it will need an ARP mapping to what? Okay, it's going to want to go back to 10.0.0.1. Yes? Okay, let's put that in. Minus s 10.0.0.1 0, 1, 2, 3, 4, 5, G. Alright, now my ARP is set up, right? I have my MAC layer set up. So what have I just done? I just removed the whole ARP complexity from making this thing work. So now all I need to do is what? And now I can just set the overflow rules for the actual data transfers. Yes? Okay? And you might recall, having studied the programming assignment, it's actually all here for you. Right? Figure 2, push OpenFlow rules. It's right there. That's what we want to do now. Okay, now I need to figure out a little bit about the command line way of doing this, right? So you'll have to Google it or look at the man page or whichever way, or both, look at examples. But basically that's what we're going to do. And so I'll give you the command. I really feel like a baby spoon feeding this one. You like that? Shame on you. I don't know who said that. Alright, here's the command. Alright, so let's look at this. So the command is OpenVS OpenFlow control. We're telling it to use OpenFlow 1.3, right? Because we pulled the switch, that's what we're going to do. So we better do that. If you don't do that, by the way, it'll say version inconsistent or something like that. You can say add flow, you're going to say to S1, that's the only switch we have in our topology. And then here's the magic, right? So this is the match, and then there's the action. Okay, so the match is import, and I actually didn't see if I needed the import, but let's assume I do. IP, destination address, that's the one we're going to match on, and then we're going to modify the destination to 5 and output it on port 5. Now, let me tell you, I was fussing around with this morning, and really part of the usefulness here is you're going to mess things up, right? So I messed it up, and I started, and I'm like, the example I looked at, this is the danger when you look at examples, it had output 5. And I'm like, okay, well, I'll just add mod after it. And nothing happened. Why didn't anything happen? The output has to come to the end. Okay, so if you have the output first, it's going to say, oh yeah, let's do the output. Oops, it's gone. Now I can't do the modify. Okay, so this is the usefulness of playing with these things. All right, so let's do that. And now let's do the jump thing again. And look at that. Ain't that beautiful? We have a flow rule. I have all this junk in here, but then here it is. The map on IP, input port, the destination address. It's going to modify it output to 5. Okay. So now I can do a ping. So well, let me say, is the ping going to work at this point? No. It's partially going to work. Why can I say partially? It'll get there, but it won't get back. Why not? Well, I didn't set up the backward rule. Right, but let's see. So if I do a ping -C1, what does -C1 mean? Yeah, 1. Okay. And I'm going to say 10.0.0.10, which is my virtual IP address. And so now we want to look at what shows up in, oh, I didn't start up my TCP dump again. Oh, actually it's the same thing here. I want to start TCP dump here. and I'll run the ping from over here. Ping, no. H1, ping.
Oh, it has to be in the system.
Thank you. This so H1 ping, then the 0.10. Okay? So oink. Oh, I forgot to do the minus C1. Why didn't you guys tell me? Right, so here it is. Right, and again, sorry for those who can't see it, but over here you get the ICMP coming in. It actually did try to send back the response, right? Because we kindly set the ARP up for it. So it's working. It's coming through from H1 to H5. If we look at this one down here, you can see the requests going out. And so this is nice, right? It's 10.0.0.1 going to 10.0.0.10. Over here it's 1 to 5, as you would expect. And so now all you need to do is to set the rule the other way around, and you would have it working end to end. Okay? Yeah.
So if I have this clear, then ARP is a way of just obtaining MAC addresses from IP addresses that ping implicitly uses, but we are explicitly setting up on each node in the network.
In this case, I set it up explicitly. Yes. Right?
Does the switch also have an ARP table?
Switch does not have an ARP table. Okay. Now, so let me just, and I'll follow up on Prince's question in a sec. Everyone clear so far? Right? You understand the strategy? Okay, now, once you have it in this state, you basically know what those rules should look like for it to work. Now you would go and you would study those examples in Rio, what was it, app, somewhere on that directory, right? You'll look at those examples, and now you can take those examples and modify them for your, you don't have to magically do everything from scratch. So now you would modify them and try to recreate flow rules programmatically that look like this. For a single flow, that's it, right? For a single interaction. And then once you have that working, you say, okay, well now we need to do it between all of them, right? Now you generalize your code. And once you're there, all you need to do is then say, okay, well for the assignment, I can't hard code, I can't do this ARP trick. I need to deal with ARP as well. Now you go to the next step and you say, okay, I'm going to receive the ARP. I'm going to have to set up flow rules to make that go to the controller. In the controller, I'm going to do the resolution on behalf of my little network, and I'm going to send out a response. Or at least that's one way of doing it. Okay, but what have I done now is I've broken this up into simpler problems. I first work on here's the functionality, then I do the programming, then I do the ARP piece. That make sense? Questions?
So when your switch rewrites that first ARP, does that not get entered in the first node's ARP table?
So your switch, so you can't actually rewrite ARP, right? If you go read the assignment, there's notes at the bottom that says you can't do that.
It sends the correct MAC address back.
It sends back a MAC address based on its load balancing decision, right? So in this case, right, let's say I have 5 and 6 on my real servers, 1 through 4 on my clients. And let's say, like in this case, we'll say, well, the first one is going to go to H5. So when I get that ARP request, I'm going to return the MAC address for H5, right? And so that's really when I take the load balancing decision, as it were, right? Because at that point, things are set, and now I'm just going to push the flows.
Right, but then let's say the H1 re-requests to the virtual IP address. would it use the MAC address of H5 because it previously got, like, would it send a new ARP request even though it already got a MAC
Just
address?
ask the first part of your question again. If H1 does what?
So let's say you do it correctly the first time.
Yeah.
H1 sends a request to the virtual IP.
Yeah.
You send back the MAC address of H5.
Yeah.
Then if H1 requests again to the virtual IP address, wouldn't it already
It will
assume
use
that it's gonna
whatever.
be the
Yes.
same MAC address?
Yes, it will, and that's fine, right? I mean, so the problem you've identified is, well, once I've done this assignment, so for so long as that, I mean, ARP tables time out eventually, right? But that's a long time. So for long as that mapping is there, H1 will always go to H5, right? Because it's gonna, you just told it that's the MAC address, and so it's gonna believe you, right? That's okay. And again, that's a problem if you were to do this more generally. But again, the way you want to think of this is we're abusing ARP here a little bit, right? The fact that this is in one LAN means there is an ARP and you can use it to trigger the whole process. In a real load balancing, it's not the way you would do it. It'd be way more complex, but this is a relatively easy way to do it. I feel like I still haven't answered your question.
I just have like another small example.
Go, yeah.
Right, so then, okay, so H1 then has the MAC address of H5, right?
Yeah.
And then
And it thinks that it's the MAC address for 10.0.0.10, right?
Right,
Yeah.
right. So the next time it's not going to send another ARP request, but you still need to rewrite the destination IP.
Sure,
So
but
what if you rewrite it to 6 and then you got a mismatch?
then you write a mismatch. And so we won't, right? So we won't do it like that. And in fact, if your code works correctly, you're only going to make that decision the first time, right? Because you only make the decision based on the ARP. And since there won't be another ARP in perpetuity, that one's going to go to H5, or at least long enough for us to evaluate your code. Yes?
Okay, I have two questions. First, I want to make sure I understand the OBS OFCTL. That is you're running that on like the main node essentially. Is
Yes.
it configuring the switch itself, or is it changing the way that the controller, like, because we don't have a controller currently functioning, correct?
You're right. The way you can think of this is, this is a command line option that is telling the operating system on this switch that happens to be running there, issue this command, right? Set up this flow. So, conceptually, the way you can think of that is that this command line is acting like a remote controller, right? Except there's no program behind it, but it's going to construct a message, an OpenFlow message, that will be sent down to the switch or down to the mininet environment, and it will be interpreted there, and then based on that, it's going to do the action, right? So from the mininet environment, the fact that this command is coming from the command line and not from a real controller doesn't matter. This is the beauty of protocols and interfaces, right? I mean, once you've defined the interface, so long as you speak the language of that interface, you're done, right? You had another question?
Yeah, my second one, you said that switches don't have ARP tables. Is it like the OpenFlow protocol? Part of my question is that, like, if I get a ping request or a request that needs to go to a specific MAC that I already know, does our switch already just have those MACs assigned to a port? Like,
No.
do I have to do that, or?
No. So if you have a traditional layer 2 switch, right, and we'll do that in the next chapter, but we did touch on it briefly in here. If you have a traditional layer 2 switch, it is what we call self-learning, right? So it has that, the self-learning is kind of, you know, if you were to think of it in your environment, that would be what your program is doing in Rio to do that. Right? Now your program is not doing that. I mean, it could, but it will probably just confuse things. So I recommend you don't do that. Right? So if your task was to implement a simple switch like the one in the example, right? Then you would have to do this learning. So you would get a packet coming in. Based on that, you would make a forwarding decision. You would probably, in that case, well, let me step back further, right? In a normal LAN environment, ARP is broadcast. So it'll just go everywhere. So the fact that we're intercepting it is kind of funny, right? I mean, we're kind of abusing the fact that we can do that. So in a normal layer 2 switched environment, these ARP requests will just go everywhere. Everyone will get it. Right? The switch will broadcast it because it's going to go on a broadcast address. And then whoever gets that and can answer it will respond, and again, that'll go to everyone. Right? And so we're abusing things a little bit here because we can. Okay, other questions? Yep.
Just to clarify, so then when we send out an initial ARP request from one of those, the piece that will answer ARP request is going to be our virtual server and our,
Yes.
our controller we write.
Yes.
It's not going to patent.
Yep. Now, there's probably other ways of doing it, but I think that's
That's
probably the
what you do.
easiest way to do it.
Okay.
Yeah.
So traditionally it would flood with the ARP, right? The switch would flood, and in this case, we're sort of, and the reason that it floods is so that it can kind of learn who's at which port.
Correct.
In this case, we haven't done that because we preset the ARP table.
Well,
so-
your application decide the ARP resolution is the way to think of it, right? Because in reality, we're lying, right? You're asking for, the H1 is asking for 10.0.0.10, and we say, oh, use H5, right? So this is not true.
So my question is, how does the switch in this case know which port the MAC address that it's sending a packet to is on, without having that initial like flood and response?
So, and that again, and this was his question in the beginning, right? So we know that because we set it up.
Okay, so
right?
that's
And again, so that's cheating, right? It's not general. Okay. I hope that helped.